Welcome, everyone. This is the first day of the PASS Summit. It's the last session of the day, and so we're very thankful for you to give us your time, and now that you're probably very tired and have your brains fried for the session throughout today.
Yes, the party. Yeah, this is just killing time to the party.
Okay, so
there we go.
that's fine. So
well, then let's just breeze carefully
we'll
along.
breathe,
Yeah.
we'll relax, because there's drinks after that, which is good.
That's right.
Okay, so the topic today, as you see on the stage, on the screen, is the intelligent database story, specifically the intelligent query performance features that we have both in SQL Server 2019, that was announced yesterday at Ignite, and Azure SQL Database. And so first, let's do some housekeeping. Please silence your phones. There's a number of things for you to explore with PASS and the community, so take advantage of that. My name is Pedro Lopes. I'm a PM in the SQL engineering team. I work mainly in the relational engine, which is a part of the database engine that deals with the query processor and performance and all of that stuff.
Great, and my name is Joe Sack, and I'm a program manager on the query processing team, embedded within Azure SQL Database, but the features that we work on are both Azure SQL DB and SQL Server.
Yes. Okay. So this will be the agenda for the session. We'll be talking a little bit about our intelligent database vision, if you will, which is just starting. And then we'll move on to what we've actually done already in the product that you can use today regarding this vision, and specifically because we both work in performance in that area. So the vision that we have for an intelligent database is multifold, and it's not just about performance. It actually tackles a number of areas. For example, the first area being around anxiety-free upgrades. So I can't really see the screen, which is usually a problem for me. Let me just do this so I know exactly what I'm discussing right now. Perfect. Okay, so the first has to do with having anxiety-free upgrades. So the possibility and our vision that you can traverse through the versions or move to a versionless database, which is Azure SQL Database. And don't fret, don't have anxiety on moving the database there and thinking, oh, will I have regressions, will I have performance issues? We have been working towards making that progression and that path one that's anxiety-free. So we'll be talking about some of this in my session on Friday, but this is definitely part of a larger vision for an intelligent database. The idea is that in the end, the engine, the database, should adapt to the running conditions of your business as data flows in and out of your databases. And we need to provide you with a predictable level of performance that doesn't drop, it doesn't require you to worry about what's coming next. For this, we've actually released a few tools already. For example, the Query Tuning Assistant, which is not the focus of this session. I'm going to talk about that one on Friday as well. And something that, for those that use newer versions, the automatic planned regression correction. Now, actually, I told Joe I wanted to start with a show of hands, and I forgot about that. But who's using SQL 2008 here? Just wanted to know a bit about the room. Okay, quite a few. Let's jump to 2012. Okay, quite a few more. I think everyone that uses 2008 knows that July has come and gone. Yeah. What about SQL? Let's jump to 2016.
Wow.
Good. 2017? Oh, wow, okay. So a lot of this is probably not new for you. And 2019, is anyone using 2019 already? In production? No one here. Yeah. There are customers in production today with SQL Server 2019, just so you know. So it's not a completely out of place question. Okay, so that's good to know. And so that feature, automatic planned regression correction, is probably something you know. The next pillar of our intelligent database vision has to do with performance. And this is where we've been working mainly, us, as in literally us. The topic of today's session being intelligent query processing, but also other automatic features that improve performance of your database servers, sometimes even without you knowing it. For example, in SQL 2016, automatic soft NUMA became a default. So it's just an example of how we try to improve the engine, sometimes with features that you don't even have to literally enable or know they're there, but just by moving to a new version, you start taking advantage of those scalability improvements that will derive in better performance. There's also the management by default. Now, what we mean by this is there are a number of features embedded into the engine. And again, this spans both Azure SQL Database and SQL Server, because one thing it's important to keep in mind is that it's literally the same database engine, which is part of our anxiety-free story. You are today in SQL Server 2008. You can take that database, you can move it to SQL 2019, to Azure SQL Database. And if you keep the same database compatibility level because you didn't have time to test, for example, the engine will behave the same for you. So it is that peace of mind that I was talking about. But here you have features like accelerated database recovery that Pam talked about in the earlier session. And those you can take advantage just by moving, just by upgrading to a newer version of the engine, again, across Azure or SQL Server. And even without touching the way the database compatibility level, you take advantage of these. So again, scalability and intelligent features that just help you when you move along the path of newer versions. And then there's security, because the tale is not complete without security. And here we have a number of features that we've done a few strides, namely on Azure, around the vulnerability assessment, around, for example, data classification, important when you need to know which data you have in your numerous databases that may have sensitive data. And for example, for those that are bound to GDPR, when a request comes in from a European citizen, for example, like me, and says, I need to know everything that you have on me, on your databases. Maybe you have, like Microsoft does, thousands of databases across thousands of instances and servers. We need to catalog that data because we need to know exactly where to go to be able to answer those requests. And this is the kind of feature that can help you do that.
One quick thing I just want to mention. So you see intelligent as a prefix for a lot of things. And yes, it is very much marketing. It's very much we're creating this way to corral a bunch of different features together. And I just want to say that it is often helpful. I'm sure for those of you who have been working with SQL Server for the last few years, there have been features that you might have found out about because it was on a CSS post at one point. Like Bob Dorr might have written about some obscure but very powerful feature, and then it got lost in the mix because it wasn't part of any big push. So a lot of what you see for intelligent database, intelligent QP, yes, I have a little bit of an allergy of like, oh, this is marketing, but yet then it's more star quality than table variable deferred compilation or memory grant feedback. You have these long names that are very descriptive. This is a way for you to have an overarching visibility to what we're doing in a cohesive way that accrues to performance.
Yes, and accrues to more intelligent manageability for you to be able to use your time in ways that the engine can't do automatically. So therefore, for you guys to have more quality as professionals dealing with this database engine. So yeah, like you said, so it's a little bit of marketing, but it's also about giving you the perception that intelligence, it's not only about performance, it's about creating a more aware engine that in the end, you can focus on your business and leave the rest to the engine, or mostly. Now, this is a vision that will take years to accomplish, so we're not taking anyone's job. Just wanted to put that out there. Okay, but today's topic is, like I said, intelligent query processing, and this is where we're going to spend the rest of our 75 minutes. So just to give you an overall vision of what we have under this umbrella that we call intelligent query processing with SQL Server and Azure SQL Database. By the way, I'll keep using SQL Server, but it's for the scope of this session. It is a synonym of Azure SQL Database because, like I said, they are exactly the same database engine. So we have a number of features here, as you see, and a few of them are not new in SQL 2019, but they are completing the story, and as we will keep completing the story as we move forward. This has very much to do with a path that we've set ourselves into that will ultimately have a self-healing engine. That's my vision, at least. And that's where we want to be at.
Yeah, we're right. So by the way, we between the two of us and a bunch of engineers, we actually have an engineer and another PM from the team here as well. And the overall goal is we want this tree to actually get bigger and bigger and bigger and bigger. There are a lot of different problem spaces that we would like to attack and address, and we're at the foothills of this. So, okay.
Yeah, so as you see by the names, which are not that sexy, of each feature, they are designed right now to try to deal with a specific problem space, a specific anti-pattern that for years has afflicted some SQL Server workloads. So the ones you see that are bold are the ones that we introduced now in SQL Server 2019, and like I said, in Azure SQL Database. And the idea is that these should be available by default with little to no implementation effort, which means that you shouldn't have to change your code for the most part of these features to take advantage of them. What you need to do is flip the bit, change the database compatibility level to the latest, and that unlocks all these features. Now, there's also a reason why we gated all these features to database compatibility level. That's not a topic today, but I'll deal much more on that on Friday. The idea is to deliver, if you move the database compatibility level, deliver broad impact to your workloads, namely those that are critical workloads that run in parallel, and you can really scale up the performance of those workloads and don't worry about them. You don't necessarily need to be a rocket scientist in order to extract more performance of your existing code, because we can do some of that for you. So this is a code of a customer that is now in production in SQL Server 2019. We have a couple more that are shown throughout the session. And they are today using intelligent query processing, amongst other features. And what they did was they moved their databases of that application to SQL 2019. They flipped the bit to database compatibility 150. And with practically no code changes, they changed 10 store procedures out of a few hundred. They got over 90% improvement. Now that speaks something. And that's the kind of real world value that we're trying to talk about today. So let's dive into the first one.
Okay. Memory grant feedback.
There you go.
All right. So we'll do a few fundamentals. I saw hands raised for SQL Server 2017. How many folks in 2017 are actually on compatibility level 140? Okay, wow. All right, that's really good to know. And then have you seen memory grant feedback, the batch mode kick in? Okay, I see 2 thumbs up. Okay, awesome. All right. So just to give a little baseline information, memory grant feedback is related to the fact that when we have cardinality estimates during query compilation, we have to make a good or educated guess based on statistics, heuristics, assumptions, different models. We try to anticipate how many rows are going to flow through a query. So if I'm selecting from a table, joining to another table, I have a predicate, then we try to estimate, okay, am I going to get 10 rows? Am I going to get 1,000,000 rows? And if we have good statistics and we're able to use those statistics, we're not going off model, then we have a scenario where our plan ideally reflects reality. And when it reflects reality, usually performance is good. All right. Now, for this particular scenario, if I estimate 1 or 2 rows are going to flow through a query tree, I might have a very small memory grant. If I think that billions of rows are going to flow through, or I'm going to have to order billions of rows or do a hash operation, then I might have a much larger grant. Now, when we get it wrong, the way that memory grant feedback works is it will see that we either overestimated, so we're looking for anything that wasted more than 50% memory, or anything that spilled to disk. So if we had a sort or a hash operation spill to disk. And then based on that information, so based on that spill or that wasted memory, we will then mark that cache plan. So on a consecutive execution, we will correct that. And we will, if it's a spill, we'll add more memory plus a little bit of a buffer. If it's wasted, we'll reduce the memory plus a little bit of buffer. And you see in this little flow, it's the first execution, and then you see it's growing, so it's still adjusting. And then at a certain point, if we see that it was enough by that second execution, then we stabilize and we keep that amount of memory grant size. And I'm going to just switch over to, oh, and actually just one quick thing here. And actually, let me move this up so I can see this a little bit better. So we talked about the conditions where this happened. Batch mode 140, so compatibility level 140 in SQL Server 2017 applied specifically to batch mode, which meant at that time, and we'll talk about other aspects that affect this now, at that time that meant a column store index was in the mix. All right, and that was our conservative first choice. Before we opened up this feature for everything, we wanted to get this in for batch mode execution. For SQL Server 2019 and Azure SQL Database today, under compatibility level 150, it also applies to row mode, which basically means if you spill or you waste memory in either execution model, we're going to address that through memory grant feedback.
So all your queries are covered?
All your queries are covered, yeah. All right, so let's hop to IM4. Let's make sure this shows up. Okay. How's the zoom it, by the way, in the font? Is it big enough? Okay, good. I heard that was a theme today. Okay. So, by the way, so one thing I'm doing, I actually ran this before this. I just want to show you something. In the query execution plan, we've added new attributes to give more information about whether or not the plan, and this is an actual execution plan, whether the plan had memory grant feedback affecting it. So I'm going to actually just start here to show you this is a nice plan, no spills. You're not clear actually if I've wasted memory yet, but we'll go ahead and hover over the select. We see the memory grant's about 625 meg right here, okay? And I'm going to go ahead and go to the properties, and we'll go ahead and expand memory grant info. And you're going to see new attributes, and this is as of SQL Server 2019 and also in Azure SQL Database today. You're going to see these new attributes. Is memory grant feedback, and is it, this basically tells you, is memory grant feedback operating against this particular plan? And you're also going to see the, this was here before granted memory, and then you can look at the used versus the actual granted and compare the two. One thing that I'll mention right here, we have different phases, and this is in Books Online, so this is documented. And if you go to aka.ms WAC IQP, you'll see the full reference, but we have different status updates. So that includes status updates like, no, this is the first execution, because this is feedback. Inherently, we don't start off with memory grant feedback. We have adjusting, we have stable. We also have something called disabled. And the disabled is for the parameter sensitivity scenario. Let's say you have a parameterized workload and you're coming in and sometimes, let's say 50% of the time, you need a small grant, the other 50% you need a large grant. Well, you're in no better shape than you were before memory grant feedback. So at a certain point, we'll actually disable the adjustment. So just be aware, we've added this to the plan. And now I'm going to execute this particular query, and I'll speak to it because this can take about, 40 seconds to run altogether. So I'm going to execute this here. And by the way, I added a comment. I had a demo, like a webcast recently, where they're like, is alter database scope configuration clear procedure cache good for production? Because I had it up here. And now I have a little comment that this is just for demo sanity. So I don't, if I get lost in the woods, I just reset things. But no, this isn't something that I would want people to normally run all the time unless it was absolutely intentional. Okay, so I have this query that I know is going to spill on a fresh compile. And I'm doing all kinds of things that you wouldn't want to do. The stats are out of date. I've got a hint in here that's hash. Usually this takes about 50 seconds altogether. And this should be the first initial compilation. And if it spills or if it wastes more than 50% memory, then memory grant feedback will kick in. And it's very lightweight. We see, indeed, there's a spill, all right? And indeed, if we look at the memory grant size, we're asking for 1 meg. Now, I'm just going to go ahead and execute it a second time. Now, it took less time, and if we look here, the spill's gone. And again, you already saw the adjusted version of it, so I kind of showed you that I started in the middle. Now I'm going to execute it one more time. And assuming it didn't eject from cache, let's go here. I'm going to go to properties.
So you're not, the plan remains in the cache?
It remained in cache, but on my laptop, you know, so things happen.
That's
yeah.
your feature. Okay.
Yeah. Yeah, so it actually has observer overhead. Like when I'm on stage, that's when it ejects some cache. So yeah, it's a magic laptop. So you see, yes is stable. So we will keep with this, okay? All right, now, some things, I wanna put all the information out up front because there are ways that we can extend this further. You might be wondering, if it ejects from cache, do I have to learn that all over again? Yes. Okay, in the current state, if you fail over, we have to learn over again. If you eject from cache, we have to learn over again. If there are the normal reasons why you would normally actually have a recompile, we will reconsider that scenario. Now, there are arguments to try to persist this, and that's and we're aware of them. But we thought that this was adding enough value. Like we know, one of the estimates we have for Azure SQL Database is that the biggest theme is wasted memory. And if you have a lot of wasted memory, you can get resource semaphore and actual pileups where you're just waiting for your grant, and you can have concurrency issues. We estimate that you could have millions of these requests being helped in the cloud today. I mean, that's just very, very common issue. All right, so let's hop back to the slides. All right, so any questions on memory grant feedback? Otherwise, I will.
There's one there.
Oh yeah, yeah, please.
The threshold of 50%.
Yes.
Can you be configured?
So the question is, can the threshold of 50% be configured? No, and it doesn't. And I would actually, afterwards, if you don't mind, I would like to hear scenarios, okay? Because SQL Server 2019 just shipped, so it's always good to hear feedback around this time. Yes, another question, yeah?
It does not require query store to be turned on.
Question is, does it require query store? No, it does not. Yeah, second question.
Sort of a follow-up. If you're forcing a plan for query store, can it was stable? So previously had memory graph feedback adjusted, stabilized, can you force it? Can you keep that setting going? Or is our recompile then flush that out?
So the question is, if I like force a plan through query store, will it be in effect? I don't think so.
No, it will not.
It will not, yeah. So your query store will be the one that's honored.
It's not a property of the plan that remains in cache. It's something that we keep, calculations keep
I gotcha, I
cached,
gotcha.
but not in the plan cache. So
Well, one thing I do want to mention though, if it's forced, anyway, if you don't mind bookmarking that one with me, because there's actual scenario that I want to dig in deeper. And we had one more question, one more, and then we'll keep going. Yeah. So the question is that optimized for ad hoc workloads? Does that affect this? Orthogonal? Yep, it does not. Yeah. One last question, then we'll keep chopping. What's that? Any overhead? No. I mean, well, okay. All right, let me back that up. Okay. All right. Oof.
not noticeable.
Sorry, got ahead of myself. Yeah, there's always a little bit, but if we talk about the instruction set, and we actually have the engineer, Kendall, here, who owns memory grant feedback today, raising hand, and it's very lightweight.
shouldn't have done
It's
that.
very lightweight. Okay? All right. Let's keep moving. And we're going to just go through a lot of the main areas that were introduced over the last 3 years. So the other one is on the subject of batch mode. And in terms of batch mode, think about it this way. If I had that, you saw that query execution tree, and in the row mode execution, at the CPU level, we're processing one row at a time. So we really are at that CPU level. We have a set of instructions. We're applying them one row at a time. With batch mode, we introduce the capability in conjunction with column store indexes to do a vector of rows at the same time, so not up to 900 or so rows. We are able to work with that same set of instructions. Just SQL Server is a program just like anything else. So if you think of the C++ programming, being able to apply across a set of rows at the same time versus one at a time. And coupled with column store indexing. So I want you to delineate between, you have column store indexes, I/O benefits that can be very significant because I store at the column level. If I'm doing a subset of columns, let's say I have a relational data warehouse pattern and I'm just doing 3 or 4 columns out of that fact table, those are the ones that go into memory. I'm not pulling everything with it in the row model. And also if you're thinking I'm storing by column, then I'm also getting potential compression benefits that can be significant. Now, coupled with this, introduced in 2012 was batch mode, and this was the second half of it, like I mentioned, and they were dependent on each other, and you could really get significant CPU benefits, again, because you're taking that same set of instructions, but you're applying it to a vector instead of one row at a time. Now, what we started to see over time is that there were scenarios where people couldn't necessarily add a column store index. So I might have a scenario where I only can have one table, and it's affecting my OLTP, my transaction processing workload, too much. So I don't want to add it, even though periodically I have analytic type patterns. Second scenario is maybe the vendor doesn't support it. Maybe there are issues where there's a restriction on column stores that if I add it, it removes some scenario that I want to use. I think trigger is one example of it. And then, by the way, we started to see things like, I think Itzik wrote a post in SQL Server magazine about the filter 1 equals 0.
I call it the hack.
Yeah, so the ability to get batch mode without actually having on-disk storage. And we heard from other customers, like, I want the CPU benefit, but I can't add the column store index. And so what we did is we added a feature called batch mode on row store. And this adds support for batch mode in conjunction with heaps and B trees, and that includes a new scan operator behind the covers that can evaluate bitmap filters. So when we're talking about bitmap filters, if I have another part of a tree where I'm actually filtering the rows, then I can use that educated bitmap and push it elsewhere so that we're not doing excessive I/O in a scan. And what we're doing is we're opening up existing batch mode support. So everything there's a big grid in SQL Server books online about all the different batch mode operations that are supported. We are just saying, look, for B trees and heaps, we're opening up that support. One other thing I just want to mention, and we'll get to the conditions and then I'll show a demo. This is opening up the option. We are opening up the search space. So we look at a few different simple attributes of the query that are that's being executed. If it seems to be an analytic type pattern, then we will consider it. We'll open up the optimization space. We'll look and see if we estimate that it could be a significant benefit over row mode, we will go ahead and use that. What I will say though, is that this is for analytic workloads where you are CPU bound. If you're IO bound, I would say please still consider column store. Consider a scenario where you can, if you're worried about affecting HTAP or OLTP scenario, moving that to a separate data set. So conditions, analytic pattern, CPU bound, and then for whatever reason you can't create a column store, those are the conditions where we're seeing customers are seeing the most benefit so far. And let me just switch over here. We'll see it in action. Okay, so I have, let me kick this off again. I'll speak to it because sometimes it can run for anywhere from 20 to 40 seconds. And it's going against line item, and I'm doing aggregation, return flag, line status, a sum of quantity, extended price. And by the way, I have this hint in here, disallow batch mode, because I am running under compatibility level 150. And this is our before query, so I want to just show you what it looks like. And this particular example is pretty short-lived. It's not running for several minutes. It was like 18 seconds. But I just want to show you, this is what we would expect. Storage, row store, execution mode, row. No surprises there. All right, so this is our current state of affairs.
So if I was running in SQL 2017 under even 140 compat level, or here in 2019 under 140 compat level, I would see this.
Yeah, that's what I would expect to see. So we shave, and again, this is not an extreme example, but we shaved off some seconds. Same query, but this time you're going to see we have row storage because I didn't magically add a column store, and then we have batch for the scan. If we go up the tree, hash match, you'll see batch. You see for the sort, again, we see batch. And so in this case, we estimated that this would be beneficial, and so then we used it, and sure enough, it improved performance. Any questions on this before I switch back to the slides on batch mode on row store?
There's one.
Oh, yeah. Yes. So Victor's question is, are there any scenarios where you can get a regression by having this on? All right, and thank you for doing that, because this is actually a good time to talk about this. In the query processing space, there's a reason why we lock everything behind compatibility level, all right? And so because there's a risk of regression. If you think about the overall customer base for SQL Server and Azure SQL Database, I think what was the quote we saw in this morning's keynote? It was like 5 million databases in Azure SQL DB and far more in the SQL Server population. You've got OLTP, HTAP, analytic patterns. You've got big, small, every possible thing under the sun, plus add ORM, and then all bets are off, okay? So With that said, we lock it under compatibility level. When you're ready to turn it on, you might see regressions. And one of the scenarios, Victor, would be if I'm misestimating. So I might kick off batch mode on roaster where I wouldn't necessarily want it, or it might not kick off when I would want it. So for each one of these pieces of functionality, with the exception of a prox count distinct, which is not really under compatibility level because it's a new function, we have 3 things and then sometimes 4. We have, first of all, you can always take down the compatibility level. That's the broadest one, not the one we recommend you start with. We have database scope configurations for each one of these options. We have query hints for every one of these options. So if you want to disable it for just a specific query, you can do that. And then for scalar UDF inlining, which we'll talk about, we have all of those, plus we have the ability to say for this actual scalar UDF, disable scalar UDF inlining. Okay? All right. So another quote here, and
Yeah, this is better known as BIWIN. And again, there are also a customer that's using SQL 2019. And as you see here, another customer that benefited from intelligent query processing features, a number of them, especially this one, batch mode and row store. They operate large data sets. A large portion of them are not eligible to use column store. It's a completely OLTP throughput workload. So they saw benefits from that. And memory grant feedback.
yeah.
Because that also helped them to actually be able to scale up.
And that's actually a really good tie-in. All this stuff is interoperable. So there are scenarios actually where our demos get a little strange, where you'll see we'll block things so that you can isolate out which feature was adding the benefit. So you could have an adaptive join with memory grant feedback, with scalar UDF inlining, table variable, deferred compilation. It could all be part of the...
All these work in tandem, or may work in tandem. If your workload is eligible for, your single query is eligible for any of these features to come into play, they will. And not just, oh, I'm picking one, so therefore the others are excluded. Everything can come into play. So that's really important to know. Okay, so the next one has to do with the ill-famed objects that are multi-statement table-valued functions. Who here has code that uses MSSTDFs? Just a few, and the others don't have it, or they don't know they have it, which can be the case. So historically, multi-statement table-valued functions, so MSSTDFs, just because it's a mouthful, are one of the several objects in SQL Server that we kind of treat like a black box. And that's because they're objects that only exist, that only materialized at runtime. So that means that when we compile a query and eventually when we throw it to the query optimizer to come up with a query plan, we don't really know how many rows can be stored in that object, because that all depends on your queries, your workload, how that is populated. So what we did before SQL 2017, and specifically before Database Compatibility 140, because this mapping does exist, is that we guessed. And that's a term that Kim uses, I like very much, guesstimate.
Yeah.
We guesstimated that a number of rows, 100 rows would come out of that object. And if you were lower than that or around 100 rows, the resulting query plan would be possibly efficient enough. But it so happens that if you actually have 1,000 rows or much more than that being populated into that MSSTDF, and then we need to use that MSSTDF to join with other tables and drive joins up to 3, then that becomes very inefficient, because guess what? The query optimizer just worked with a large difference between what's reality and what was estimated. So interleaved execution, what we'll do is that when we're compiling a query and we're starting optimizing a query, we go through the query space and we find a MSSTDF. When we do that, we stop, we step out, we'll materialize that MSSTDF with whatever number of rows need to come in because your code says so. And then we'll step back into compilation and we'll use that actual number of rows to drive more decisions to eventually come up with an optimized plan. Now, this means, for example, what you see right now is that if we had 500,000 rows instead of 100, that those 500,000 rows are the ones that we'll take into consideration when optimizing the rest of the plan. So therefore, you may derive into a radically different decisions. Now, one point I want to make here is that once the plan is cached after this decision-making process is done, the plan remains in cache. So if your first population of the MSTDF was the traditional use you make of that MSTDF, then you're fine. If actually to that MSTDF you have a very varying number of rows, a big oscillation there, then you are in essence stuck, if you will, with the first plan that you calculate, because we just do this materialization once. Okay, and this is enabled, by the way, every one of these features, as if you notice in the top right corner, tells you what is the minimum database compatibility level that you need to set your database for that feature to work. And you've seen that in the previous slides as well. So let's look at MSTDFs actually working. And
while you get that set up, I just want to mention one thing. So MSTDFs was a natural first candidate for interleaved execution because it was already being materialized. So we obviously couldn't add materializing of a row set where it had not existed before. Otherwise, you would have had overhead that we might not outweigh whatever bad estimate that we had. So that was part of the prioritizing scenario of why we picked MSTDFs. Also, it's a huge anti-pattern. It's very, very popular along with scalar T-SQL scalar UDFs.
don't get ahead of yourself.
Yeah,
We'll get there.
yeah, no,
We'll
I
get
don't.
there.
No.
So can you see in the back?
It's not showing up just yet.
It's not showing. Oh, because I don't have my screen duplicated, so that's why. There you go. Can you see it now?
Yep.
Awesome. So for this, I'm just gonna set the database to the minimum compatibility level I would need to enable this feature, which is 140. Although I am running in SQL Server 2019, as you see here. And so I'm going to use this database here. Okay. So what I have, as you see, is sorry, this is the wrong one. This is what I wanted. Okay. So using this database, by the way, these demos are publicly available, so you can use them yourself, and I'll give you the link in the end. First thing is I'm going to create a function, and the function, as you see, will return a table. So the multi-statement table value function. And it has a number of conditions here. So depending on the type of event, as you see, we'll insert different types of data, different result set into the MSTDF to then later be used to whatever calling query we have. So let's just create this, this function here. As you see, it's rather complex. Okay. So now I'm going to show you the legacy behavior, if you will. What would happen if you have either on SQL 2019 or 17 a lower compat level, or B, if you're using, for example, SQL Server 2016 or a lower version. And again, for the sake of the demo, I'm cleaning the procedure cache. So don't do this in production. Okay. So what you see here is a query that's fairly simple. It does join the fact order table with the table value function I just created here. And then it has a number of input parameters. And finally, I join the to the neither table. So it's a fairly simple query at face value. If you would look at this query as is, you probably think it's not too complex because it doesn't really show you the complexity that you have inside that TVF anyway. So let me grab the actual execution plan. There you go. And this should take this should be quick enough. There you go. So if you look at the actual execution plan, here's what we see. Let me try to bump this up. So you see a few things. There's a few hash matches here that have spilled, which is obviously a problem for the most part, specifically because you see that it wrote quite a few number of pages to disk. Every time you go to TempDB, especially in a large spill like this, can be a problem. But what I want to call out is the table scan, which is the scan done on that MSTDF. See that the output was actually 231,000 rows out of 100 rows estimated. So if you're using a newer version of SMS, it will actually tell you all this information just at face, and it will also tell you the percent skew value that you had between actual rows and estimated. So this, because it's a baseline, if you will, data source that we're reading and then building up the tree, then will affect every decision that the query optimizer took from then on. And because it was estimating just a few rows coming from this, we got into this shape that you see here. All the decisions were driven by the cardinality estimation, that in this case was pretty low, just 100 rows coming out of this object. Okay, so clearly a performance problem. By the way, if we go into the root node here, and I can look at the properties just to take note of the time here, query time stats, and I can see that the elapsed time was 4.1 seconds with 1.1 second CPU. Just let's make a mental note of this. So now let's move to the minimum compat level we need to use interleaved execution. And again, clearing the cache. I don't want to necessarily use the same plan. And now we're going to execute exactly the same query and see where that leads us. So the first thing I noticed is it was quite fast. If you look at query time stats, instead of 4.1 seconds, 1.4, and instead of 1.1 seconds of CPU, just 400 milliseconds. So that's pretty good right there. The other thing I notice is the shape of the plan is radically different. So it's a much more linear tree. And if you look in closely, the table scan is now one of the tables used in this hash match now is using the right cardinality. We stepped out, we materialized, and then we use that information to derive further decisions of the query optimizer and come up with the plan that you see here. So right there, without code changes, as you noticed, just by bumping up the pcompat, this feature worked for me. I now have a much better execution, a much better result without any code changes. Any questions so far? Let's switch back to this. Yes, absolutely. So for this table scan, you see that there were the same 231,000 rows as we've seen in the previous execution. Now, out of the same 231,000 rows estimated, whereas before we had that magic number, 100 rows estimated. So with that, because it's one of the inputs of this join and for my query, obviously, then that was used by the query optimizer to drive different decisions because the cardinality is much bigger than it was with that magic number. And that will then lead to decisions about where to place this table, whether it's a probe table or the hash table of this hash join. And that then, if we're using a hash join here, what's the next join point? And that drives up to 3 in terms of decision making. And it did it on the first execution, yes. That's actually how this feature works. It's only on the first execution. Only on the first execution do we step out, we materialize the MSSTDF, we'll use those actual number of rows to drive the decision tree of the optimizer and then come up with a plan that is cached with this shape, with these cardinality estimations already there.
And you're making a really good point, by the way, kind of the meta point of being that there's lots of different ways we could do this. We're learning on the first compilation. Pedro's going to show you something. I won't steal the thunder on that one, but there's intra execution, there's feedback loops, and then there's just different assumptions that we build in. So we're hitting at different angles.
So this is one of the classic anti-patterns that we hit because it's very useful from a developer standpoint to be able to instantiate MSSTDFs. But then we have the counterpoint that during execution, historically speaking, SQL Server did deal with these inefficiencies if you had a lot of rows going into that type of object, right? And now you can overcome that. Another question? Okay, so the other feature that it's under the Intelligent Database umbrella is batch mode adaptive joins. Now, this is also available as a minimum at the 140 compat level. And as the name suggests, it only works in batch mode. The good thing now is that we have batch mode over row store as well. So that means that potentially batch mode can kick in with whatever indexes you use. And therefore, another piece of the story where if you have batch mode and row store kicking in, it's possible that you also see adaptive join right there because one thing complements the other sometimes. Okay, so a classic problem, a classic anti-pattern here is that historically in SQL Server, whenever we compile the query and come up with a plan, whatever choices we made to join 2 tables from a physical perspective, those were the choices you were stuck with as long as the plan was cached. That means that, for example, if we had it wrong, meaning if we had skewed statistics, if we had misestimations in terms of cardinality, that means that maybe we would choose a hash join expecting a large number of rows, and then a small number of rows comes in, and probably a nested loops would be more efficient, or vice versa. So the point is that with whatever plan you had in SQL Server, however we decided to join two tables, that's the way it got cached, that's the way it got used for whatever queries use that plan. Now, we could actually use an inappropriate join algorithm, and that became a problem, and you would see that, you would perceive that as an inefficient plan, and you would see probably a regression, albeit temporary, in your workload. For example, you would go and recompilate the query or something like that. Okay, so what adaptive join does, it will actually, it's a new operator in the plan. So it will actually, a plan that uses adaptive join will actually get cached with a new operator called adaptive join. And you might find it strange, but it's the first join that actually has 3 inputs instead of 2. And I'm going to talk about that in a few minutes. So what adaptive join does is it will defer the choice of the physical implementation of the algorithm. So how will my inner join, for example, between table 1 and table 2, will actually be physically implemented, whether through a nested loops or a hash join, depending on the number of incoming rows. And because it defers that choice to runtime, that means that if a plan is using adaptive join, the plan that's cached remains the same, but between executions, if the number of rows that flows through the join is different from one execution to the other, we will adapt on the fly, meaning during runtime, to that condition that we're encountering. So in essence, what we have is we have a build input. It's whatever tables are being joined in my query, and we calculate something we call an adaptive threshold. It's a threshold above which we will either switch to a different type of physical implementation or remain with the one that we were running. In essence, if the threshold, which is again dynamically calculated for each execution, goes above, the number of rows flowing through goes above the threshold, we will switch to implement a hash match, because a hash match is typically can provide better performance and scalability for a large number of rows that are being joined. Whereas if a smaller number of rows are being joined, then typically nested loops can become more efficient. So therefore, if we don't go above that threshold, then we will resolve that join as a nested loops. So this is all done in runtime, as I said. Yes, and this is the point I was doing right now. So the threshold is dynamic. Like I said, it's from query to query. And let's see how this works actually in a demo. Any questions so far? Yes, one right here.
Are you then getting out of using statistics at all? Because you could just sample like this?
Good question. So the question is, can you get off not using statistics anymore because we can now see in runtime how many rows are flowing through? That's not the case. We still use statistics for a number of decisions. Even to understand if adaptive join is possible, we use a combination of techniques, and part of that is still statistics. So it is still the building block for the query optimizer decision making to have metadata available over the columns that we will use from the tables that we will use. That decision process doesn't remain only at joins. We have a number of operations that will benefit from accurate cardinality estimation. And so the simple answer is no. You want to add something?
No, other than just to clarify, it's compile time, we do that inflection, that point of the threshold, and then on consecutive executions, it's the same threshold until that plan gets ejected. Okay, just a slight nuance there. There was one question, oh yeah.
Yes.
You just mentioned that the threshold is dynamic.
Yes.
So the query, imagine the input. Any guidelines to try to understand what that threshold might be for any particular query?
We don't publish the way we calculate the adaptive threshold.
Yeah, it's just think of like an intersection point literally on a curve of when we would normally do, but like Pedro said, it's not, we don't actually publish the algorithm, and that's always code for we reserve the right to change it a little bit or
exactly.
adjust it. So, okay.
That's exactly the case. Yes, but you'll see in this example how from execution to execution, the adaptive threshold actually changes. And then a decision is taken after that, either we cross that threshold or not.
Yeah.
Question here. Is that an additional overhead? So I will actually paraphrase Joe. With any of these with any of these features, there will always be an additional some additional overhead. It's most likely negligible, and it is negligible for all the workload that we've tested. What this does essentially is that when we have not made the decision to do a nested loops or to do a hash join, we're building a structure in memory called the adaptive buffer, like I mentioned. It's when we make the decision that to either complete the query using nested loops, in case we didn't cross the threshold, or B, if we did, we'll move to a hash join, that structure is repurposed to become either the outer table of the nested loop or the hash table of the hash join. So that it may not even be measurable, but from a code perspective, yes, there's more code running than if you were to make the decision like we did in previous versions to just stick with one or the other and cache that value.
Yeah.
If you are using legacy kernel information for database, so to use
Good question. So all these features that we are talking about today are they have that minimum compatibility level that you saw in the top right-hand corner, which means that you need to be at least in that compat level for that feature to just kick in and eventually help your workload. Otherwise, if you're using the so-called legacy cardinality estimator, so C70, then no, none of these features are available, which is also part of the Anxietyfree upgrade I mentioned earlier. You want to be able to move from SQL 2008 all the way to SQL 2019 or Azure SQL Database. And if you keep the same database compatibility level, you want stability. You want to know that what you know of your workload remains. Whatever performance you had at least remains the same in terms of not having different decisions made by a newer query optimizer, not having those potential variables introduced into what could be otherwise a dangerous upgrade, right? So we want to keep stability. So that's why we gate all these features behind specific compatibility levels.
So I'll just get,
Oh,
I'll add
the
a nuance to
database
it. So
scope.
here's the thing. You will not have the same exact plans, but a lot of these features will kick off with legacy. They will kick off with legacy, but you will not
With
have.
the database compat level.
So if you are,
with
if I'm at compatibility level 140 and I have legacy C, a lot of these features will kick off still. However, it's optimized, like Pedro said, for the most recent. And so that's the big nuance.
So you
yes,
meant
you can,
a mix of newer DB compat
Yeah.
by activating either trace flag or the DB scope option of forcing the legacy C. Okay.
So since with an adaptive join, since the hash requires more memory than the nested loop, the initial memory grant that's requested accommodates the hash. And there isn't like an on-the-fly adjustment of the memory grant.
There is in the sense that with batch mode you can actually go above the initial grant, and that's just a characteristic of running batch mode. So one of the many uses of having proper cardinality estimation, therefore using statistics, is that with proper cardinality estimation we are able to properly, I would say, quote unquote, estimate the amount of memory grants that we would need for that query to execute. But if we're running in batch mode, if that memory is not enough, we can go above the initial grant. And that's just a characteristic of batch mode. And if you would look at an actual execution plan that suffered from that, suffered is not the right word, that has found that or encountered that characteristic, thank you, it may be enjoyed. Because the point is, we want to run in memory as much as possible. A batch mode, imagine starting to spill that, obviously becomes even more of a problem in terms of expectations than running in row mode, right? So we do allow ourselves to go above the initial grant, and you would see a warning in the actual plan saying that you went above the initial grant. Okay, so I don't remember if I clear the cache or not. Let me do this. I'm going to create a store procedure. And you see here that it just gets, this is one of the TPCH queries right here. So it gets the top 100 of a few tables, and it joins with a correlated subquery here. So let me just execute this and get the actual plan for it. Okay, let's execute first and see what happens with this input parameter 314. And hopefully I did select the actual execution plan. I think I did. There you go. Okay, so let's look at the plan here. I'll try to bump it up as much as possible. Okay, so you see actually 2 adaptive joins kicking in this plan. Let's move to this first one over here. So in this adaptive join, you see the adaptive threshold rows were 1,527, right? But the actual number of rows were just 85. So with 85 rows, obviously we didn't go above the threshold. And as you see in the second line over there, the logical operation was an inner join, and the actual join type was a nested loops. So that's the choice that we made. Why? That's a default choice. If you don't go above the threshold, we'll actually implement the required join operation with nested loops. Now, if we go to the other join, because in this query we do have 2 adaptive joins, we see that the adaptive threshold for this one was 1,146. The actual number of rows was 599, so therefore below the threshold. And again, we resolve this as a nested loops, as you see in the third line over there. Okay, so this plan was cached as is. So it's a plan that's, if you go and look in the DMV that gets your plans from the plan cache, you'll see a plan exactly with its shape, just without the numbers here, because these are runtime. So what happens if I, again, because the plan is cached, I just execute a store procedure now with another input parameter. Now, as you probably know, I'm going to reuse the plan that's in cache, assuming that during my demo the cache didn't get cleared. And it's taking some more time. The point here is that we're going to reuse the same plan. And for this new execution, each of those adaptive joins, should they kick in, actually they will kick in, we will find a new adaptive threshold for each of them. And then again, on the fly, we'll make the decision, did we go above the threshold? We'll resolve either as a hash match or B, remain as a nested loops. This should take about 45 to 50 seconds. If you want to know, for example, if this is a long-running query and want to know what's going on, one of the features that you can use in 2019 is right-click using SMS. Right-click on the instance name, select Activity Monitor, and when you select Activity Monitor, you can go to the processes. This is session 116. So if I go to the processes, let's just give it a second while it's still executing anyway. And does need to populate, so I can't tap dance. Do you want to do something, Joe?
Let's see. Oh, actually, well, then let me follow up on one of the points. So Lonnie's question was about, does it have overhead? There's a very distinct reason why we did not say row mode adaptive joins, because you think about for OLTP-centric, transaction processing-centric workloads, do we really want to actually introduce that risk versus something that's kicking off batch mode? There's a certain assumption that it's a larger result set, it's an analytic type pattern. So that was definitely one of those risk trade-off decisions that we made. Like Pedro mentioned, with batch mode on row store, it opens it up. So if we estimate that it's going to be big, you can start leveraging it without the presence of a column store. But it's very unlikely that we will add row mode adaptive join as a standalone version of this. Okay. Was that enough tap dancing, or?
It was not.
Okay, all right.
So,
yeah. Oh.
My activity monitor is
It's paused.
Oh, it is
okay.
paused because it took too
Nice.
much time. It took too much time. But the query is complete anyway, so let's just go here. Okay, so I see the plan as the same shape as I would expect. One thing that had happened now, by the way, look, there was a sort spill. So that's probably because I don't have the proper amount of memory grant. But I do have another feature in SQL Server that we just saw memory grant feedback in the next execution. This would kick in. Anyway, let's look at the first adaptive join right here. And what you see is that the actual join type now is a hash match. So the adaptive join was now resolved as a hash match. And that's because the adaptive threshold rows are 1,527, so 1,527. But now the actual number of rows that traverse this join were 66,000, so obviously above the threshold. So then we did the operation I mentioned earlier. We resolved the join with a hash match. If you go and look at the other one, let's see what happens. On this one, this was again resolved as a hash match. The adaptive threshold is 1,146, and again, a lot more actual rows traversed through the join. Now the plan is the same as I said, it's cached as is, but we make these decisions on the fly on how to actually implement the join so that we can do that in a more efficient way for the actual number of rows that are flowing through. Yes? So the question is if reporting the actual threshold is new. That's since we released a feature, that's always been a feature of inside the show plan. You may have caught a version of the UI in SMS that didn't show it in line as you see here, but it's always been inside the show plan.
In early CTPs for sure, it was not.
Yeah. In early CTPs it was. Now, not always the graphical UI will render all the information that's inside show plan. So sometimes it's useful to actually look inside, and sometimes we need to unlock as it was the case here and in other aspects. We need to unlock the visibility of the information that you find inside show plan. Yes, question there. Potentially for every execution, it will be adjusted.
It's for initial compilation. It gets fixed. It's fixed. Now, if it gets ejected from cache, you could end up getting a different threshold. Yeah. So if there's different stats, we might end up getting a different intersection where that tipping point is.
If I recompile and I now start with this, then I'll get a different threshold, yes. To check the information about what's the... If you need to rephrase the question.
So the BM is to find memory grant feedback has happened, right?
Okay, so the question is, how do you detect if memory grant feedback? So there is not a standalone dynamic management view to view it. Right now for memory grant feedback, there's the query execution plan as of this latest compatibility level, and then also X events. Mm-hmm. But we of course see the value of a holistic. It's on the list. It's one of those things where it's a scoping. And it looks like, by the way, I think we have 13 more minutes, correct? I'm just doing a time check. So we will be available afterwards for questions, but we'll probably hold any more longer questions for the
absolutely.
rest. Yeah.
So let me try to keep speed up here. Yeah. So another anti-pattern that's seen in SQL Server has to do with the use of table variables. So again, a very popular method of populating a temporary structure to then be used for the query. Now, the legacy behavior, meaning before 140 compat level and therefore before SQL Server 2017, would be that amongst another, by the way, you see here the typical comparison between when to use or what can I benefit when I use a temporary table versus a table variable. Now, the aspect that I want to call out here is that when a statement references a table variable, it's again another type of structure that doesn't exist until runtime. So therefore, it doesn't get populated until runtime, which is another black box for the optimizer. So that means that we again resort to a magic number or a guesstimation. And the guesstimation that we use historically is just 1. So if you had just 1 row going into that table variable, fine. So even with the magic number, we'd get a good plan. Probably you never got just 1 row in those table variables. So therefore, you got into, again, a scenario that we probably got an inefficient plan and you get to performance problems. So using 140 compat level, and this is wrong here because it's 140 compat level.
There you go.
In the corner, right there. What you get is a different behavior. We will, similarly to what we do with MSSTDFs, when we encounter a statement that references a table variable, we'll actually defer the rest of the compilation until we can materialize and know how many rows exist will be populated in that table variable, and then use that actual cardinality to further optimize the plan with that in mind. So we'll just, again, similarly to what you have with MSSTDF, you'll have a plan that's more appropriate for the use you want to make out of it. So I'm gonna speed up the demo, but this is just, oops. Let's look at this one.
And by the way, on aka.ms IQP, if you go all the way to the bottom of the intelligent QP topic, there are links to demonstrating adaptive query processing, which was the terminology we used as the feature subset in 2017. time frame. And then there's also demonstrating intelligent query processing. That will lead to different GitHub links that have all these different demos that you can reproduce everything that you're looking at today. Every single feature in that feature tree, you can get hands-on. It uses a slightly modified version of Wide World Importers DW.
Okay. So because this takes a while, I actually executed this one before. Still in 140 compat level. Okay. So what I've done here, as you can see, the legacy behavior is that okay, line items. So for my MSSTDF, although 750,000 rows were populated, and then therefore you scanned out of this object, only one row was estimated. So obviously then that derived all the decisions up to the query tree. The query optimizer carried out its work with obviously a large skew in terms of cardinality estimation, and that drove the choices that we see here in the plan. So look at the shape very quickly, and in terms of time to execute, we can go into query time stats here, and one thing that we see is that the query took 32 seconds to execute with roughly 8 seconds of CPU. Okay, so now let's do the same thing, but by moving to a higher compat level, and let's again run the same query. So we had roughly 8 seconds of CPU time and 30-something seconds of elapsed time. Let's see if Activity Monitor works for us now before the query stops executing.
Oh, Activity Monitor.
It does take a while to get populated. So, and last I won't be able to probably show you the feature I wanted to. So this is taking a while here. Let me try to do the same on this other server. Okay. It should be much faster than it is. So always have a backup server, which in this case I do. And let's see what happens when I execute on this one. So it should be less than 10 seconds. That's my expectation. And there you go.
Beautiful.
Roughly 10 seconds flat. Okay, so as you see now, look at this. I was now able to use the actual cardinality to drive what is clearly a different plan. Namely, now I'm using parallelism, so the cost of the plan was higher. Now we knew that during compilation time, which meant that this query was eligible for parallelism. And in this case right here, if I go back to query time stats, it just took 2.3 seconds. So roughly the same CPU time, but obviously because it's non-parallel, and it drove different decisions of the optimizer, and I obviously got better performance out of this. Okay.
All right. So with that, I'm going to optimize for show instead of tell. Let's go to, okay. So here's the deal. We have this deck. You're going to have access to this deck. I'll go over approximate QP with whatever time we have left, and then also scale UDF inlining. But I want to show it to you. We'll actually go through the demo, and I'll explain what you're looking at. And by the way, is Parag still here? Oh, so Parag, the engineer for approximate QP, was here, and he's like, hey, who's that other presenter going on in that other session? I'm like, really? This is your feature. So he decided to go to a different session. He said he'd come back.
He
All
does
right.
know
Well,
approximate
we shall
count
see.
distinct, so.
We shall see. Maybe I won't present it now. All right. So here's the deal. We've had feedback from customers, both internally and externally, that there are scenarios where sometimes approximate is good enough, especially when we're talking about billions of rows, lots of data flowing through. Let's say you're having to do telemetry, sensor data, and there are scenarios, let's say you're doing a graph and you just want to look at trend lines. Is it going up? Is it going down? By what magnitude? Another example is data science scenarios. I want to see the number of distinct elements in a column. And there are certain operations like count distinct, and I'm going to run this, even though this is under compatibility level 150, this is actually outside of something that you have to worry about with compatibility level because it's a new piece of functionality. But I have this count distinct order key from line item, and if I hover over the query execution plan, the key thing I just want to show you here is this very large table. I'm just doing a pure count distinct, but it's 1.5 gig of memory grant, okay? Now, no problem if it's just me. If I had 10 more of these requests, you're gonna start gating, all right? So one thing that we added, and I'm gonna be very interested to hear feedback over time because there are other areas we could potentially focus on like approximate percentile and other areas where not only would it be helpful for workloads to get approximate values. By the way, don't use this for banking. Don't use this for anything where you
Yes.
must, you know.
I don't want to know my approximate
yeah.
bank statement. I want to know
Yeah,
the,
please don't. Yeah, so long as it approximates that,
even
very
though
good.
then I have legal problems. So.
Yeah. So here's the deal. The other query that was count distinct was 15 million. This is 15.164704. The general algorithm, or the algorithm that is used is called HLL, hyperlog log. You can read about it in Wikipedia. The general guarantee is 2% error range within 97% of the time. But this is the punchline. If you go over the select, you're going to see a very small footprint. So it uses probabilistic methods to generate an estimate that's within that 2% range with a very small memory footprint. So we're talking 12 meg.
I counted that number. It's 97.46%.
Oh, there we go. Okay, good. I stand corrected. Yeah. All right. So that's approximate QP. And again, I will be interested in feedback because this is one of those things where you're seeing us test the water, where we were getting people asking about it, but then sometimes it's context-based, and I don't always hear as much feedback as I would expect. But if there are other approximate functions that you would be interested in or scenarios that you think that this would match, I would love to hear about it.
We have the contact in the end.
Beautiful. Okay. All right. So then one last thing I want to show, and we're going to then wrap up with just a few more questions so that you can go to the party, is scalar UDF inlining. And I'm actually going to kick this off while I talk through it because this one can take a few seconds to run, and I will, don't worry, I will show you what's going on. So I have a scalar UDF. It takes a part key as an input argument, and I'm using it as part of a where clause here. And I'm producing a quantity, an average quantity that I spit out, all right? And now I'm referencing this calc average quantity by part key in my select right down here. And one of the issues that we have with T-SQL scalar UDFs, and Pedro started to allude to this earlier, which is it's a black box. It runs in serial mode. It's a scenario where for each row I go out and I do this operation. So we're not doing any optimizations. If you have multiple statements within that actual function definition, we're not optimizing across those statements. So it is a pure black box, and from a troubleshooting perspective, as a DBA, it can be very difficult because if you look here, the plan is serene. Like it just looks very straightforward. We've got a scan, we've got a sort, we've got this compute scalar, but no problem, 0% cost. And then I've got this missing index. That's what I need to do. I need to add that missing index. Totally rational, okay? And serial mode. So what is this functionality, scalar UDF inlining? So what we'll do, I'll execute it. This time I'm not going to use the hint. So I did this use hint disable T-SQL scalar UDF inlining. And just keep in mind that I could have also disabled it at the function level. So I could have said turn that off, or I could have done it at the database scope configuration. I could have also decreased the compatibility level. So this shaved off a few seconds. It's not extreme, but this particular example shaved off a few seconds. If we look at the execution plan, now if you don't like execution plans, then you're like, boy, this got worse, because it's like sprawling and there's all this. But the whole point is it's not a black box anymore. And then it also opened up other things. So the functionality, and a lot of really talented folks worked on this. I'm happy to say some of them are going to actually be joining the team directly, whereas it used to be a cross-team partnership. Karthik included, they did this paper that there'll be a link in the deck on. But in essence, there are things that we can move from imperative to relational. So I can translate certain imperative statements, and there's a slide on this that I'll show, that we can actually stream into relational equivalents, and that's what we're doing on the fly. So what does that do? It opens up proper costing, it opens up things like parallelism, and ideally it gives you an appropriate plan shape because we're working with all of the information. All right. Oh, and by the way, one quick thing. This is a last-minute request. If you want to know whether your statement, if this is a result of scalar UDF inlining, there is an attribute in here. Here we go. Contains inline scalar T-SQL UDF. So you will be able to see that in the plan. If we've converted it over, it will show up. there are different things, and we'll see in the slide deck. Let me hop back here and grab this. Oh, thank you. You put to the imperative then. Okay, so this is just a few examples. So if we see here the set, select, and you just see a few different translations, we do that on your behalf dynamically. One thing I do want to mention, so you have the concept of I have these UDFs, okay? And then I have statements that reference the UDFs. Keep in mind that there's that differentiation. That UDF might be inlineable, but how you use it in a statement may not be inlineable. And we have a list of different things where it could potentially be non-inlineable. Some of these were conservative choices, like anything side effecting, like around dates, this new sequential ID. Those ones, we didn't want to risk it. Other ones are actually surprisingly common. The one that I wanted to mention is the computed column, actually, and check constraint definition. We're hearing that feedback a lot. So for a V2 of this, if there's any priority scenario, we'll show you the email at the end. I know we're at time. I do want to mention one thing about this functionality. This is another one where we think it's going to have huge impact because, again, developers love these functions, and they are everywhere. And so just by bumping up compatibility level 150, it would be worthwhile for you to see what kind of impact.
We told developers for years to use them.
We told them for years, and then we paid the consequences.
Yes.
But this is from Mediterranean Shipping Company.
Yes, so we got another one that's using, amongst other features of SQL Server 2019, adaptive query processing and intelligent query processing. So we've done this part. So the features that we saw today are, like I said, in SQL 2019 in Azure. We continue working on a number of other scenarios, so please use that email if you have other ideas or if you have feedback for us.
Yeah.
If it's support requests, then it goes through support.
Yeah.
But we want to hear more ideas, and if you're seeing things that you don't think you should be seeing, then those obviously also qualify.
Yeah. IntelligentQP at Microsoft.com. Please feel free to use it. Even interesting scenarios where, like, when are you going to address X, Y, Z? As program managers, we use this as raw material for making business justification. So,
Yes.
this is very helpful to us. Thank you. We know you had a lot of great choices. We also know it was the end of the day. Appreciate you spending this hour with
Don't
us.
forget the evaluations. And
Thank you. Yeah, you can come up with it.
One quick thing I didn't mention that we had a few links. We have a number of SQL notebooks that actually go through these detailed demos with screenshots and all. So SQL 2019 notebooks, you can get those.